The internal rate of return. So this is the most important alternative to the net present value. It's widely used in actual practice within businesses. It's appealing. It's based entirely on the estimated cash flows, and it's independent of any interest rates or discount rates. The internal rate of return is the discount rate that makes the net present value zero. The decision rule is that we would accept the project if the internal rate of return is greater than our required return. So for the net present value versus the internal rate of return. So the net present value, we use a required return rate or discount rate, hurdle rate, interest rate, whatever you want to call it, and solve for the net present value. The internal rate of return calculation gives us a net present value of zero and tells us at what rate the net present value equals zero. These two decision factors, net present value and internal rate of return, are often used in conjunction with each other. Without a financial calculator or Excel, computing the internal rate of return for a project is a trial and error process or a guess. In a calculator, you enter the cash flows as you would for the net present value, and then press the internal rate of return button and then calculate. If the internal rate of return comes back higher than the required rate of return, we would accept the project. So we have an example here of how we would put it into a financial calculator. And then with Excel, we use the internal rate of return function, which is IRR. You would enter the range of cash flows beginning with the initial cash flow. You can enter a guess, but it is not necessary. The default format is as a whole percent. So if you want it as not a whole percent, you need to reformat in Excel. We will, of course, look at this in our examples. So this is an example of calculating the internal rate of return with Excel. The formula is IRR, and then within the parentheses, you select all four cash flows. This project has an internal rate of return of 16.13%. So this is, if we're doing, this graph shows a net present value profile for the project. So how the net present value changes at different discount rates or interest rates, and the internal rate of return is where that crosses the zero line. So it's where the net present value for the project is zero. The advantages of internal rate of return: one, it's preferred by executives because it's easy to communicate the value of a project. You can say, we have a return of 16% on this project. It's appealing to just hear a number. If the internal rate of return is high enough, you may not have to go through the other estimates to determine, because if the internal rate of return is over your required return, you already know that means the net present value is positive. It considers all cash flows, it considers the time value of money, and it provides an indication of interest rate risk on this project. Disadvantages are that it can produce multiple answers. So if you have unequal cash flows, and in some of the years you have negative cash flows, so if you have more than one negative cash flow, so consider an example where you have the negative cash flow out at the beginning of the project. We have to put money out, and then 4 years later, we have to do some kind of repair or maintenance to continue to use the project for another 3 to 4 years if we're looking at a piece of equipment. If that mid-year mid-time cash flow has a negative value, just like the initial cash outflow, the project will return more than one internal rate of return, which is obviously not helpful. It's not as easy to rank projects with a different internal rate of returns as it is with the net present value. And it has a flawed assumption of reinvestment. So with the internal rate of return, it assumes that we can reinvest all of our cash flows from this project at that rate. The net present value and the internal rate of return will generally give the same decision. The exceptions to that are if the cash flow sign changes more than once. So when I was talking about if we have more than 1 year with negative cash flows. If only year 0 is a negative cash flow, they'll return the same decision. If we have another year with a negative cash flow, then the IRR method is not useful to us. If we have mutually exclusive projects, so with different initial investments, with timing of cash flows is different, it does not help us reliably rank projects. For those non-conventional cash flows, that's where the cash flow change signs more than once. The most common cash flows are that we have an initial cost that is a negative cash flow, a stream of positive cash flows, and then a negative cash flow to close the project. For example, a nuclear power plant or a strip mine. If we have more than one negative cash flow, we're going to have more than one internal rate of return. Which one of these should we use to make our decision? Which one is the correct one? So this is called the Descartes rule of signs. With a polynomial of degree where n is the n roots, when we solve for the internal rate of return, we're solving for the root of an equation. We need one root per sign change, and the rest are imaginary. So we're going to look at these non-conventional cash flows, and we're also going to do an example in class with non-conventional cash flows. So suppose an investment will cost $90,000 initially and will generate the following cash flows. So in year 1, $132,000, in year 1, $100,000, in year 3, $150,000. The required return is 15%. Should we accept or reject the project? So the net present value is greater than 0 at 15%. So we should accept. Using a financial calculator, we get an internal rate of return of 10.11%, which would tell us to reject it. So when we look at the net present value, we have to recognize the non-conventional cash flows. And we can see that the first internal rate of return is 10.11%, and the second internal rate of return is 42.66%. It's common for a project with multiple cash flow signs to have 2 or more internal rates of return. So we're going to look at this graph then. We're crossing the axis more than once. So there will be more than one return that solves the equation. So we have 10.11% and 42.6%. When we're looking at independent versus mutually exclusive projects, independent projects mean the cash flows of one project are unaffected by the acceptance of the other project. Mutually exclusive projects means that we have to accept one project before we could accept another project. We also have the reinvestment rate assumption. The internal rate of return calculation assumes that we can reinvest all cash flows and earn that same exact internal rate of return. The net present value assumes that reinvestment at the firm's weighted average cost of capital or opportunity cost of capital, which is more realistic. So the net present value method is best. If we're choosing between mutually exclusive projects, we should give favor to the net present value method over all other decision methods. So we're going to look at an example of mutually exclusive projects. So we have two projects. The required return for both projects is 10%. Which project should we accept and why? So if we look at the two of them, we can see that the internal rate of return for A is $19.43. The internal rate of return for B is 22.17%, and our crossover point is 11.8%. So this is where project A and project B meet, where they're the exact same value at 11.8%. So two reasons for our net present value profiles to cross. One is the size scale differences. So smaller projects free up funds sooner for investment, and larger projects or longer projects take funds for a longer time. The higher the opportunity cost, the more valuable these funds. So a high discount rate favors small projects. We also have timing differences. A project with faster payback provides more cash flow in early years for reinvestment. So if the discount rate is high, early cash flows are especially good. So having higher cash flows in the earlier years gives us a better return. When we have conflicts between net present value and the internal rate of return, net present value directly measures the increase in value to the firm. Whenever it's difficult to decide between the two, net present value is always the deciding factor because the internal rate of return can be unreliable in certain situations, a couple of which we've looked at so far.